Population of a large town in New York was 19,413 in 2015. The population is increasing according to the following formula. Now, interesting that it says it's increasing, because when you look at the base, doesn't it look like it should be decreasing? Because it's 0.96. But remember, that's not actually giving us the rate right yet, because it's still not just to the t power, it's to the negative 4t power. So to be honest with you, I would probably, even before I read the question, just to wrap my head around what's going on here, I would raise 0.96 to the negative 4th power, and 0.96 raised to the negative 4th power is going to tell me that that base is really this number, so it's increasing by about 17.7%. Follow? Okay, so 1 point, I'm just going to the t power now. So just a different version of the same equation, but it makes it a little bit more clear that certainly it is increasing. And the population of the town is t years after 2015. So again, always paying attention to that detail. So you're not plugging in 2015 ever. You're plugging in 0 for 2015. So here, of course, this is what they get at. The above equation can be written in the form P equals the same starting population times x to just the t power. What is the value of x to the nearest thousandth? Tenths, hundredths, thousandths. And I obviously just happened to round to the nearest thousandth already. So x equals 1.177. If the population growth is compounded annually, what is the rate of growth to the nearest tenth of a percent? Compounded annually is already kind of what we have going on here. So the nearest tenth of a percent is 17.7% per year. Okay, so it's really piggybacking off of that first one. And then using the original formula, they want the average rate of change. Now, average rate of change is something that is going to come up on your final. What's another word for the average rate of change? Slope. Okay, so we want to find the slope from 2015 to 2020 to the nearest whole number. Before we can find the slope, we need points, right? So using the original formula, so to figure out what's going on in 2015, what am I plugging into the original formula? 0. So the first point will be 0, comma, and I'm just going to plug this into the first equation. Oops, that was the best I was going to do. 19,413 times 0.96 raised to the negative 4 times 0 power. 19,413, I should have known that, because when you plug in year 0, that's just your initial population. And then what am I going to plug in for 2020? How many years is that? 5. So I'm going to plug in 5, and instead of plugging it all in again, do you guys know this little trick where I'm just going to steal it? Exactly what I typed in before, and then I'll go back and change that to a 5. 43,920.57. And we need to calculate the slope. So now y2 minus y1. Minus the 19,413 over 5 minus 0. And then just figure that out. So I'm going to take this number that I just left off with, subtract the 19,413, get my new numerator number, 24,507.57, and divide that number by 5. So on my calculator, divide that number by 5, and the rate of change to the nearest whole number is 4902. So 4902, use appropriate units. This is going to be worth a point. Okay? When we subtracted these amounts, those were the number of people. Okay? So your numerator is people per, and 5 minus 0 was your years, so people per year. So we were growing by 4,902 people per year in that span, in those first 5 years. Okay? Any other questions on test 6? Thank you. Cole? Number 3. Oh, this was a tough one. Haley's father has been painting houses for the past 20 years. As a result, he can paint a house 1.5 times faster than Haley can. They work together. So it has been a very long time since we did this, and when we did do this, we did it kind of in terms of one day. So when they work together, it takes them 14 hours. How many hours to the nearest hour would it have taken Haley? So it's the number of hours they work. This is kind of the format. Divided by, and I'm going to put worked, divided by the, kind of their speed, I would say. That's for person 1. And then for person 2, same thing, number of hours they worked, divided by their speed, that would be person 2, equals, and you're waiting till it adds up to 1 full job. Okay? So they both worked 14 hours, so it's 14 over something plus 14 over something equals 1. And the rate, we don't know. So one has a rate of X, and the other is 1.5 times faster. So, that's a tricky one. 1.5 times faster. So if this one works, at, 2 houses per, or two sides of the house per hour or something, this is 1.5 times that. So we'll just...
Wouldn't that be 2x on the quiz?
Was this one on the quiz?
Yeah.
Do I have all the quizzes?
Yeah, all quizzes. And what's 2x on the quiz?
Okay, so I'll just go over the quiz one then. And this is such a tricky one because, first of all, you have to remember that structure. And that we talked about really just one day in the rational problem. But again, they're both working for 14 hours. What's this period? So 14 hours at the rate of X, and then the other person is working 14 hours at a rate of 2X, and we're trying to figure out how long until they get 1 full job done. So if I go to solve this, it's a rational. I need a common denominator all the way across. So this one needs to be multiplied by 2. This one needs to be multiplied by 2X over 2X. So once all the denominators are 2X and I'm solving, I can cross out. I get 28 plus 14 equals 2X. 28 plus 14 is 42 equals 2X, and X equals 21. Now, so someone's working at 21 units per hour, and the other person is working at 42. So how many hours to the nearest hour would it have taken Haley if she had been working alone? Which one is Haley? The 42. Her father would do the full job in 21 hours. She would do the full job in 42 hours. So now that we know that answer, let's kind of also make sense of that. If her dad could do the house on his own in 21 hours, if he's been working for 14 out of 21 hours, he's painted 2/3 of the house on his own, right? 14 to 21, he's painted 2/3 on his own. And then if Haley on her own can only do it in 42 hours, but she's only been working 14 out of 42 is 1/3, so she's doing the additional third. So he paints 2/3 of the house, and she paints 1/3 of the house in that 14-hour span, and that adds up to 3/3 of the house completed the job. Okay? But I think the tricky part is realizing when you're done which one is Haley and which one is her dad, and like taking a moment to process that. So even though X is 21, how many hours to the nearest hour would it have taken Haley? 42 hours. Now this one didn't work out that you had to round anything because I changed the 1.5 to a 2, so it worked out to be a nice whole number. Okay? Polynomial in degree 3. So from your flashcards, you should know your polynomial structure. x minus your root 1, x minus your root 2, and so on and so forth, right? Since this is a degree of 3, we should really have 3 roots. Your chart is going to tell you what those roots are, okay? Roots are x-intercepts, yes? X-intercepts are when what equals 0. Why? So you have a root here, you have a root here, and you have a root here. So that's x minus 3, x minus 1, and x minus negative 2. So that's x minus 3, x minus 1, and x minus negative 2 is x plus 2. And we, of course, have to find the a value. You find the a value just by plugging in an xy coordinate. And you have lots to choose from. Which one seems the easiest? What's the easiest point to plug in? What do you think? What are you saying, Cole? I can't hear you. 418, you could, but 06 seems pretty easy, doesn't it? I like the look of that because I'm plugging in a 0. So I'm going to do that, 06. You just can't re-plug in a root. So when x is 0, this will be negative 3, this will be negative 1, this will be 2. And then all of this gives us 6. Divide both sides by 6, and a equals 1. So your polynomial function, I did p of x, it could be f of x, doesn't matter, equals 1 times x minus 3 times x minus 1 times x plus 2. What format is this in? Factored. That's your factored form. Standard form would mean multiply this all out. Okay? I might look past that for this little quiz, but so you know, if they say standard form would be this whole thing multiplied out. So this would be x squared minus 1x minus 3x would be minus 4x plus 3. And then keep distributing, so it's one big long polynomial in standard form versus factored form. Did I do that on the homework key? I did? Okay, it's these little details that we can't look past when they say that, because that would be a point. Even though the context, you know the main content. And then going from standard factored form to standard form, and then just clean that up. So we've got x cubed minus 2x squared minus 5x plus 6. Okie doke. Any questions on that? And the last one, simplifying a radical. So you're taking the square root. So you're trying to break down 32 so that it's one of these numbers, the biggest one we can come up with, 4, 9, 16, 25, 36, ... right? Which of those numbers is the biggest one that goes into 32? 16. So you kind of want to break down negative 32 into negative 16 times 2. And the reason for that is because we do know the square root of negative 16. What is it? 4i. So it's negative 2 times 4i, and then the square root of 2 is still glued underneath. So it ends up being negative 8i root 2. Okay? Take out your little 6-question quiz. We're going to do that. All right, we've pretty much done almost every card, so you're going to start seeing repeats. All right, just as a heads up. Number 2. You can do this as a cosine or a sine, I don't care. Number 3. Number 4. Number 5. Make sure you tell me what the variable stands for. Austin, give me your phone, please. Not the X and the Y variables, but the other variables that are in this format. Make sure you tell me what they stand for. And number 6. Okay, pass those forward. All right, do I have them all? What is the y-intercept? When x equals 0, good enough. Parabola's vertex format looks like this, okay? As opposed to standard format. Remember, standard format is ax squared plus bx plus c, once that's all multiplied out. And what I meant when I said, tell me what all the variables stand for, not x and y, but the other ones, you have to know that hk is your vertex, and positive A opens up, and negative A means the parabola opens down. What's the continuous exponential change formula? PERT. A equals P times e to the RT power. Odd function. Symmetrical to the origin, not an odd degree. Odd degree is just polynomial stuff. That's the end behavior stuff. Odd function means it's symmetrical to the origin. If you also wrote that it looks the same right side up as upside down, I'll take it. If you also wrote this algebraic piece, that when you plug in negative x, you get the opposite of the original, that's fine for odd as well. Okay? And the trig function format. Based on what happened the last time when we had this, I do want to clarify here. A lot of people are writing like y equals a sine bx minus c plus d, okay? This b has to be out in front of a set of parentheses, okay? You have to, and you're taking the sign of the whole thing, but the b has to be factored out. So let me give you an example of why this matters. If someone gives you this, and I'll just give y equals 4 sine of 8x minus 2 plus 7. And someone asks you to identify the amplitude, what is it? 4. The midline, 7. And the phase shift. This is not the phase shift, okay? The phase shift is the C value, but after that B has been factored out. So, I probably should have done that, so let me switch it actually. I mean, it's easier one. So you have to factor out that 2 first, leaving you with x minus 4. And then your phase shift is 4 units to the right. Yep, okay? So rather than a sine curve starting right on the, the y-axis, it's going to start 4 units shifted, 1, 2, 3, 4, 4 units shifted to the right, not 8, okay? So, and then if you wanted to find your period equals 2 pi over the b of 2, okay? So you wouldn't get the b value wrong if you just pulled it from here, but you would get the phase shift wrong if that ever comes up, okay? So when you're writing that, make sure you keep those parentheses there. All right? And the last one was, hopefully a cupcake. x to the a minus b. Very good. All right. So, take out your notes. Oh yeah, pass it up, please. Thank you, Sarah. I forget. There's so many different activities going on. Keep my head straight. Grade all that. Okay. I try to think where did we finish test 5? Oh no, we didn't yesterday, right? We're still kind of finishing the last one on test 5, I think. Yes, we were on this last one on test 5 that we hadn't gotten to yet, where it wanted us to solve a quadratic in 2 different ways. So, on my sheet of paper here, I've got that quadratic written down. Here's way 1, and here's way 2. The quadratic formula I'm not very worried about, okay? It's the completing the square. Now, in the quadratic formula, you want to get it all equal to 0. So then I would just do negative b, so negative 6 plus or minus the square root. B squared in this case is 36 minus 4 times a of 1, c of 10, all divided by 2a. And the discriminant, 36 minus 40, I would type that into your calculator just to be safe, but it's going to give me negative 4, all over 2. And simplifying, what's the square root of negative 4? 2i. And as long as both of those terms are reducible with 2, I can do that. Are they? Yes. So they both can be divided by 2 to leave me with negative 3 plus or minus I as my 2 solutions. I only bring that division thing up because sometimes if it's negative 6 plus or minus just an I divided by 2, people are dividing the 6 by 2 and not the second term, which you cannot do. You have to divide both terms. If you can't divide both terms, either don't divide any at all, or you still would have to divide both terms. One might give you a whole number, the other might give you a fraction. But completing the square I want to review, because completing the square, the format that you should get is your x squared and your x on one side and your constant on the other. So I'm going to add this 6x over, but also subtract this 10 over to the other side, so it's negative 10. That's the format for completing the square, because we are completing the trinomial into a square, perfect square. What was the technique we used to figure out that magic number that's going to make that factorable into a perfect square? Half of b squared. So if you want to write that down, half of b squared. Now b is 6. So half of 6 is 3. And 3 squared is 9. So I add 9 to both sides. What that did for me is allowed this trinomial to be factorable. What does it factor into, Alexis? X minus 3 and x minus 3, though, would make minus 3x, which would be negative 6x. I want positive 6x. Right, x plus 3 and x plus 3. And so, hence the reason why that's a perfect square trinomial, because that's the same factor being multiplied by itself.
Don't they all have the same solution?
Yep, and that's what the point of this problem is for you to show that. So negative 10 plus 9 is negative 1. And now that you've got this written as something squared, we take the square root of both sides, and we get x plus 3 equals plus or minus I. We took the square root of both sides, so we need a plus or minus. And square root of negative 1 is I. Then we would subtract 3 from both sides, and we get x equals negative 3 plus or minus I. So the problem was to kind of show that you can solve them in both ways, okay? Now, as a side note, because completing the square comes up in two other contexts for us, okay? So, one of those contexts is with quadratics, I'll say. So if I have y equals 2x squared plus 6x minus 9. And we might be asked to complete the square on this. This is a polynomial in standard form, not a polynomial, a quadratic. That's in standard form. What they're looking for you to figure out is how to change this into vertex form. So I'm going to complete the square in between to turn it into that. So again, I have to get rid of the constant, so I'd add 9 to both sides. Okay? Here's the second part we haven't talked about yet. You cannot complete the square of a trinomial if there's a coefficient. And there is right now a 2. So I have to factor out that 2, which leaves me with x squared plus 3x. And I'm going to leave a little gap now. Oh, I don't like that. Can we make this 8? And 8. And then when I factor out the 2, it'll become a 4. That's going to make my life easier. It's going to make all of our lives easier. So now to find that magic number, I take half of the 4, which is 2, and square it. What is it? 4. I add 4 in the set of parentheses. Here's the catch, because we have this coefficient. What did I really just add to the right-hand side? I added 4 in a set of parentheses that's being multiplied by a 2, so I really added 8. So to counter that on the left-hand side, I add 8 as well. So I get y plus 17 equals my 2, and then this factors into x plus 2 times x plus 2, which is just x plus 2 squared. So do you see how my a value has come up? My h value has come up, and I'm just going to subtract the 17 back over, and I have my vertex form, with a vertex at -2, -17, and an a value of 2. Yes? Okay. There's one other place we'll do that again on tomorrow, but your homework tonight is Test 6, Part 2. All right, have a good night.
How was I today? What?
Sorry.
Good.